Hey, today we're talking about circles. We're talking about the characteristics of circles. So, because circles are really such perfect shapes, they really are. There's only one shape better than a circle. That's a sphere. It is the most efficient shape. It's a circle in 2 dimensions or a sphere in 3 dimensions. Most efficient shape. You get more volume per surface area in a sphere than any other figure. And with area, you get more area per perimeter than any other figure in a circle. Okay, so they're the best figures. And because it's a circle and it's such a great figure, there's all sorts of cool things that we're going to see happens in circles. So first of all, we talked about what you guys did the reading. A chord. So what is a chord? It's a line segment. It's just a line segment in a circle, okay? So in our example here, chord, AC, well, let's go with AB first. AB is the chord, okay? AB is a line segment in the circle. That's it. Now the secant is a line that goes through the circle, okay? Secant. Secant is WY, okay? So WY is your secant, right? And I'm going to trick you for a moment, but not you guys because you're smart. You ready? Because, you ready? WY like that is also a chord. Because if I just call it WY as a segment, it's a chord, right? But if I use that symbol as the line going all the way through, it's a secant. So a secant's a line that goes all the way through the circle. A chord is a line segment on the circle, okay? Actually, and you know what else is another chord? AC. Even though AC has a special name called the diameter, right? AC is the diameter, but it's also called a chord. Okay, how am I doing? Now the tangent line, that's that line that just skims it, right? So the tangent line is on the outside of the circle, and it's going to be FE. So it's going to be, tangent line is going to be FE. It's my tangent line. So my point of tangency is where it's tangent, and that's a point D, okay? Now, central angle has to be an angle at the center. Well, that's really that one right there, okay? So we're going to say angle DXC.
Why can't it be AXD?
I was hoping somebody would say that. And it could also be angle AXD. Thanks, Claire. If you didn't say it, I was going to point it out, okay? Now, this other angle right here, we're going to talk about this one later, but this one's called an inscribed angle, but not today. We're going to talk about that one tomorrow, okay? That one's called an inscribed angle. We'll talk about that tomorrow, okay? All right. So far, so good, right, you guys? Now, this is called circle. They're going to call this one circle X because the center. So you'll see the book do this for symbols, okay? In the book, you'll see this little symbol. This little symbol means they're going to say circle. There's my circle. They're going to say given circle X because they won't write circle X all the time. Okay, but that little symbol means circle X, and the name of the circle always comes from its center. Good so far? All right, pretty easy. Okay, example number 2. Okay, find the point of tangency and write the equation of the tangent line. Okay, well, let's see. Find the point. The point of tangency looks like it's right there, doesn't it? So the point of tangency would be at the point 3, 4, okay? Now, write an equation of the tangent line. So we need this line right here, okay? The way I'm going to get it, and I know an equation of a line, I'm going to use my y equals mx plus b, right? It's the equation of a line. But I don't quite know where it's going to touch, do I? But I don't even know its slope either. So here's the trick, okay? Here's the trick on doing this one. Let me draw in this line. Let me draw in the radius, okay? Can you guys see the radius? What I learned earlier, or what you guys learned earlier, was that the radius and the tangent line, the radius and the tangent line are perpendicular, aren't they? We did that in reading, okay? So what I know about the radius here, about this radius, is perpendicular to my line. Okay, know that. So So if I'm going to get an equation of a line, I've got to get two things. I've got to find the slope, okay? I've got to find the slope of this line, okay? So to get the slope of this line, first let's get the slope of the radius. So I'm going to find first the slope of the radius, right? Now we learned some time ago, and you guys know that, this slope is basically rise over run, right? Slope is rise over run. So the slope of the pink line, or the slope of the radius, is, let's see, 1, 2, 3, 4, up 4, 1, 2, 3. So the slope of the radius is up 4 over 3. How am I doing? Am I doing okay? So if that's the slope of the radius, what's the slope of the line? Well, it's got to be the opposite, right? Yeah. So the slope of the line is the opposite. Kurt said negative 3/4. He's totally right. So the slope we need is negative 3/4 because we know if they're perpendicular, they have opposite slopes, right? So far, so good. So what I did is this. Let me back up real quickly. I knew that the radius had to have the opposite slope because they're 90, right? Right, 90, right, 90. So I knew that they were perpendicular, so I knew the slope of this was the opposite slope of that. Okay, am I good so far? Okay, now let's at least put what I have. So the equation line, I'm going to go y equals negative 3/4 x plus b. Now the hard part about this problem is I'm not sure where b is. B is that line that crosses the y-axis somewhere, okay? That's my b, my y-intercept, right? But it's kind of hard to tell exactly what it is. So what am I going to do? Well, let's solve for b. Okay, I'm going to solve for b. Let's see if you guys remember some algebra. Slide over for just a second. We're going to solve for b. Okay, how do I do that? I got three variables. I've got a y, I've got an x, and I've got a b. How can I solve for b when I've got so many variables?
You can write it in the like slope. I don't know what it's called. That's that one.
Yeah, I could do that, Claire, and that is a great idea. I'm going to just actually do it the way Mr. Bard showed you. I'm going to use the other one. So, do I have an x and y value anywhere?
Yes.
Oh, I do have an x, y value. I've got a 3 and a 4, right? 3 is the x, 4 is the y, right? So let's put the 3 in for the x, put 4 in the y. So let's go 4 equals negative 3/4 times my x, which is 3, plus b. Now I can solve for b, can't I? I might have a fraction, but I can work with fractions. I can do that, okay? So let's keep going. So I'm going to go ahead and I'm going to squeeze it over here. 4 equals, let's see, that's negative 9/4. Isn't that negative 9/4? Negative, you guys with me on negative 9/4? Like I'll throw it up here, I'm running around. But this is the same thing, isn't this negative 9/4, right?
Yeah.
3 times 3 divided by 4, but that's the same as negative 2 1/4, isn't it? That's the same as negative 2 1/4. Okay, let's go back to algebra, and if you never learned algebra, I'm so sorry. I guess bummer for you, huh, if you never learned algebra. So we do the same thing as a 2 1/4, negative 2 1/4, plus b, solve for b, right? So that's a negative 2 1/4, 9/4. Add 2 1/4, what do I get? 6 1/4. I'm not done because the original equation said find the equation, but I'm almost done. My equation is, right? Y equals, well, I know my slope. Found my slope. My slope is negative 3/4 x plus b, and I know b is way up here at 6 1/4, 6 1/4. So go plus 6 1/4. Okay, that's a little bit hard of a problem, right? That's going to take some thinking. I have faith in you, okay? Okay, you ready for example 3? I'm trying to go slowly. That was the hard one. The rest are pretty easy. Okay. All right. Example 3. Okay, so when I look at example 3, there's two things missing. There's two things missing. One says tangent, so that's 90. Okay with that? Does that make sense? And 2, just like a clock, watch my clock, that's 4. See it again? That's 4. Do you agree with that's 4? So if we have to find a, b, let's use Pythagorean's theorem. You okay with Pythagorean's theorem? I see a right triangle, don't you? Got my a squared plus b squared equals c squared. So I'm all right. I'm going to go my a squared squared plus my 4 squared equals 7 squared. How am I doing? A squared plus 16 equals 49, right? I don't know. It's 49 minus 16. I should be able to do that in my head. 33. A squared equals 33, right? Subtract. Divide it up. Square root it. A is equal to the square root of 33, which I don't know what that is. I'll tell you in a second. About 5.7, or approximately equal to about 5.7, okay? That should be easy. You guys agree? Right? That should be an easy one. That should be easy. Okay, return the page. Alexa, I'll wait for you. I'll wait for you. Okay. Everybody got it? Last one. Okay, here we go. Oh, it's not last one. I'm sorry, you guys. There's one more. Okay, so I'm going to draw this thing so out of proportion that it's going to be crazy, but I'm going to draw it way out of proportion to help us, okay? So, let me go ahead and, let's see, put the Earth. Okay, here's my Earth. Okay. And then Mount Everest is approximately 29,000 feet above the sea. So let me draw Mount Everest. Now, bear with me. From space, Mount Everest does not look like that. Would you agree? No way. But it's going to help me out with this problem, okay? So that's 29,000 feet, okay? And then the radius of the Earth is 4,000. But it's 4,000 miles. So I've got two different things going on, okay? First of all, I've got 29,000 feet and 4,000 miles. Okay, so what do you want to do it in terms of miles, or do you want to do it in feet? If you do it in feet, you're going to have some really big numbers, okay? Miles. Let's do it in miles, okay? So can we convert Mount Everest into miles? How are we going to convert Mount Everest into miles, okay? So let's first of all, how many miles is that? Miles. How am I going to figure out how many miles that is?
5.5,000.
Right, everybody agree? So here's my conversion number. So let's just take my 29,000. 29,000, 1, 2, 3, divided by 5,280. And I get about a 5.5. We'll go along with 5.5. So Mount Everest is about 5.5 miles up in the sky, right? Which doesn't seem that high, but it is. It's so high that you can't even breathe up there, can you? Well, you can, but it's very few. There's been a few people who have done it without oxygen, but most people die trying to do it that way. Okay, so then, if you're way up here and you want to look out at the horizon, you say, well, how far can I see, okay? So I'm going to look off the horizon, and I can just see that right there, okay? And that's what I want to find, is that value there, okay? Now, let's see if we can set this up. So if I'm looking off to the horizon, then this is like a tangent point, isn't it? Right? That's just my very tangent point. And let's see if I can find a right triangle out of here, okay? So if I go ahead, let's see if I can scratch a right triangle out of this. Okay, do you guys see my right triangle? I know this is 4,000 here. And this is 4,005. This whole thing is 4,005.5. Okay, 4,005.5, all right? So I did Pythagoras theorem, I could figure it out, right? So if I go, all right, x squared plus 4,000 squared equals 4,005.5 squared. I'll stop and let you catch up. Okay, I want to make sure everybody can do this, okay? So there's a couple of tricks to doing this problem. One is realizing, again, I had to, 4,000, 4,000, right? The second thing is I had to change Mount Everest into miles, and so the length of this is the 4,000 plus the 5.5, okay? Now, to make this easy, I do not want it. You guys don't want, these are going to be huge numbers, right? So watch me do it in the calculator, okay? I'm going to do the whole thing in the calculator. Ready? Check it out. We are going to go 4,005.5 squared. Subtract. You okay with subtract? 4,000 squared?
I can't see it.
Well, that's just no good. Okay, there we go. Okay? There you can. So, to avoid huge numbers, let my calculator do all the work, right? We're just going to go 4,005 squared minus 4,000 squared, right? Enter. And I'm going to take the square, and that's a huge number, then I'm going to take the square root of that answer, because we're doing Pythagoras theorem, right? You guys agree with that? Let the calculator do all the work. And so I get an answer of 209.8 miles. And that's how far we can see. So about 209.8 miles is my viewing distance, okay? Okay, last but not least, which seems really small, but remember, I drew Mount Everest way bigger than it should be, didn't I? Right? I mean, that you wouldn't even see Mount Everest on this, would you? All right, last problem. I call it the ice cream cone problem, okay? Think about it. Everybody knows this, right? You got an ice cream cone? Aren't those two always equal? Aren't they? Are those two sides always equal, right? Ice cream cone, right? Morelia? Ice cream cone, what do you know about the ice cream cone? It's good. I like ice cream too. But what do I know about the two sides of an ice cream cone? I do know. What about these two sides of an ice cream cone? They've got to be equal, don't they? Don't they have to be equal? I don't need to teach that, right? We know that. So guess what? This side has got to be equal to this side, right? So let's set it up. Let's set up our 5x minus 28 equals our 3x, right? We'll go minus 5x minus 5x over minus 28 equals a negative 2x. How am I doing, okay? Divide by negative 2, divide by negative 2, x is equal to 14. But that's not the answer, is it?
Which one's DF?
Great question. How come I didn't label this? Katie? I forgot to label it. Man. Yes, totally right. Thanks, Keisha. Yeah, I would agree with that, 100%. Okay, so now let's finish it. So 3 times 14, what's that, 42? Yeah, it's 42. And then the other one has to be 42, right? Because they're equal. Thanks, Keisha. I better go back and label that for next time. Okay, so, easy, right? Homework, page 751. Draw the picture, show the work. Now, if you get it done, we got a good half hour. If you get it done and you want to do your retake or have help with your retake, that's fine. But you got to get this done before you can take the retake. All right? Okay, you got to get your homework done first. All right?